To this video, guys. In this video we will have a look at the fuel injector waveform for Porsche 993 model. So before actually going into the oscilloscope, let's move to the schematic first, where I want to explain you how this injector works in Porsche 993. So this is the injector here on the right side of the paper, and there is a supply line to it, and there is a signal line to it. The supply line will provide 12 volt, which will be coming from a DME relay. Now this relay will be actuated once we turn on the ignition. So as soon as we turn on the ignition, this circuit will be closed and 12 volt will be coming to the fuel injector from this line. Now the another side, we do have signal wire. Why we are calling it a signal wire? Because right now, while the fuel injector is not actuated, there is 12 volt is coming to it. The 12 volt is coming from here actually through the windings, and once we actuate the fuel injector, there will be 0 volt to it. Okay, so there is change in the state of voltage from 12 volt to 0 volt here. So this wire is called signal wire. Now we have 12 volt and we have ground, so this fuel injector will open and display the fuel. Now moving towards the waveform side, we have 12 volt here until point A, because the fuel injector is not actuated until point A. Now at point A, while DME starts to provide it ground, the voltage will be dropped down to B on the signal wire. Now from point B to C, the DME will continuously provide it ground, and this time from B to C is called pulse width or injector on time. Okay, now we know that fuel injector has coils, it has windings, so there will be EMF generated in it, and as soon as we reach point C, and the DME will stop supplying the ground to the injector, this EMF will be kicked down, and it will generate around 60 volt here, or it may generate more than it depending upon the car, the type of injector we have. And this energy is called inductive kick. It is the EMF, electromotive force, which is being generated here. And here you will see that at point D there is a linear line here. Now depending upon the model, if we do have a Jenner diode, we may see this line, and if we do not have the Jenner diode here, we will see that it is going to the point G. So Jenner diode has clipped the some of the excess voltage here, so it is not going beyond the 60. If we do not have this Jenner diode, it would have gone to maybe 70 or 80 volt. Now this voltage will be dropped, and you will see there is a discontinuity at point E before it actually goes to the 12 volt. Now this point is here because the fuel injector will be closed here, and it is called pintle hump point here. It means the fuel injector has been closed here. We did not see this hump while we turn on the injector. We can see that hump in the fuel current waveform, actually fuel injector current waveform. We can draw that diagram later on. Now once it crosses point E, it goes down back to the 12 volt line while the fuel injector was not operated. Now moving towards the oscilloscope, I have already set everything, and let's zoom it now and see how this waveform looks like practically in the oscilloscope. It will need to be zoomed more. Okay, here you can see the 12 volt. It is now being dropped down to 0. From 0 it will have inductive kick. It is around 60 volt, I believe. And here you can see the pintle hump. Let me zoom it a bit. Here you can see the discontinuity here. That means fuel injector is closed at this point. Now from here it will go back to the 12 volt as it was earlier as well. Now let me show you the Jenner diode action here. You will see that this line is not going beyond this 60 volt line because we do have a Jenner diode here. I hope that you like this video. If you do have any query, please post them below, and if there is some input you want to provide, please feel free to give it to me. Thank you.